Let's begin with our new topic called as resistance of a system of resistors or equivalent resistance or total effective resistance. The key idea here is about replacing. So to understand this idea, I have four different cases. So wherein we are replacing given system with something. So let's have a look at the first one. I have 10 Newton and 12 Newton pushing the box towards the right. I'm replacing this two with a single force of 22 Newton pushing towards the right. Case 2, I have two different ladders putting the box from point A to point B, two different ladders plus a platform, which is helping us in putting a box or set of boxes from point A to point B. I can replace this with a single ladder, which puts the box from A to B. Case 3, I have three different cells whose effective voltage is 15 volt. I can replace this with a single cell which gives an voltage of 15 volt. Case 4, you guys remember the resistive length? So if we leave the ball bearings over here, the time taken by the last ball bearing to move out in both the cases is what? Is it same or different? So let's have a look. So we could see that the last ball bearing exited almost at the same time. So here in path 2 and path 3, if you look at the resistive lengths, so there are two of it over here and a single one over here. So can we tell that this two lengths can be replaced with a single one? Right? This is about equivalent resistance. Right? Similar to that. Of course, it's not the same thing. The idea is similar. We are replacing whatever the effect these two are creating, we are replacing with a single one. It need not be two, it can be three, it can be any number. So basically, you're replacing with a single system, which creates the same effect. Now, when it comes to the world of electrical topic, so what equivalent resistance mean? See, I have system of resistors over here. Right? Connected to 15 volt battery, giving a current of 10 ampere, not 12, 10 ampere. If I'm able to replace a single resistor across the same voltage, giving me the same current, I can call this as an equivalent effective resistance. So the definition of equivalent resistance is equivalent resistance of a network is a single resistor, right? So we are looking, the idea is from here is a single resistor that can replace all the network's resistance, right? All the network's resistance, which gives the same effect in terms of current and voltage. So we can see for a given fixed voltage, the current flowing in both the circuit is one and the same. So we can tell this particular resistance RAB is equivalent to this resistance offered by this network of resistors or any electronic component, doesn't matter. It need not be resistors itself, it can be anything. A bulb also, you have four different bulbs. So the everything offers resistance, is it not? So 3 to 4 or any number, doesn't matter. If I'm able to get a same effect of this four bulbs, not in terms of light, in terms of current flowing, that would be the equivalent resistance for that particular scenario. So in the next section, we'll look into how to find this equivalent resistance for different cases. For now, you guys have to pause and think over what you guys want to write down. See, again, the ideas that comes to you in your mind is the one which you can write down. It need not be something from the screen itself, or it can be something from the screen. Left to you guys. But yes, write the heading in your own terms. You can put your in my own word. You can put that and write down the idea. Again, please make a habit of making running note. It's useful for your subjects like English, any languages to be frank, then social, then yes, science and maths too. So any idea oriented or thought oriented subjects, actually all the subjects are so, you should make running notes, right? So please pause and write down few of it. And here, write down the definitions and the circuit diagram too.